We do a lot of ways of making electricity. We do some wind power and we do some solar power, but a lot of what we do involves water from the Tennessee River. And so it's called hydroelectric power. What's your root word, hydro?
It means water.
Absolutely, hydroelectric power. So it means using water to make your electricity. So sometimes we have a dam and the water falls over the side of that dam and it turns these big turbines and the electricity comes out. Up where I live, we have steam plants and we borrow the water from the Tennessee River and we push it into this big power plant and we heat that water up so hot steam comes off of it. And the power of that steam turns the turbines that makes that electricity. And then that electricity, have you seen those big power lines that go down a field? That electricity goes down those big power lines and then it goes into smaller power lines. And I think Upper Cumberland County Electric, is that who you get your electricity from, maybe? Lacey, is that right?
Yes.
Okay, Upper Cumberland County, they take that electricity and then they bring it into your homes and your schools. And so all of that started with the Tennessee River. And I don't know if you can see that, but that's the Tennessee River starting up here in East Tennessee, and it dips down a little bit into Alabama and a corner of Mississippi and comes back up through Tennessee and into Kentucky. And so all of this general area is able to get electricity made from the Tennessee River. So what are some things you guys do with electricity that you like?
Use electronics.
Electronics.
Use maybe fans to dry or cool something off.
Absolutely. For like a fan to cool things off. What else do you use electricity for?
Fireplace.
Fireplace. Click on a fireplace with one of those remote controls. Yeah.
TV.
Your TV. Absolutely.
Our stove.
The stove. Hey, cook your food with it.
Microwave.
And the microwave. My kind of cooking.
Dryer and washer.
The washer and dryer. You know what my favorite one is? When you open the door to the refrigerator and the light comes on. Well, it's kind of like magic. Because how are you going to find the good food in a refrigerator in the dark? That ice cream is always back there in the back. So we do a whole lot with electricity. And it's really an important part of our life. And so we actually hire someone. It's a career. They go to school and then they get a job, maybe with TVA, and they're called an environmental scientist. And I think they've got a pretty cool job. They spend part of their time in a boat, and they go up and down the Tennessee River, and they get a bucket, and they collect water. And then they write down where they got that water, and then they take that water, and they go into the science lab. And they do all kinds of experiments on the water to make sure that when we make that electricity, we aren't doing anything to hurt that water. So today, I wanted to ask you guys if you wanted to be a scientist with me and do some of the same experiments that the TVA scientists do when they check the water on the Tennessee River. Is that good with you guys?
Yep.
All right. So, we do a lot with that Tennessee River. We stop it and we drop it and we heat it up, and we want to make sure we don't hurt it. Do you guys ever do anything fun on the water? What do?
Swimming.
You go swimming,
You drive your boat and hang out.
boat riding, and just hanging out, chilling on the water. Jet skis, wakeboarding.
Fishing, but what our family does instead of keeping the fish, we put them back in the
We just do a release. There you go. What do you do on the water?
Tubing.
Tubing. Anybody ever just skip rocks? Yeah. So that's a pretty cool thing that you do on the water. And so maybe, have you ever seen where, you might have seen it in real life, where a deer might come up to the edge of the water and get a drink? Yeah. So wildlife uses our water. All of us play on that water. So TVA takes very seriously, when we make your electricity, we want to make sure that we don't harm that water. So today we're going to do some experiments, and we're going to check 4 qualities of the water to make sure that if those qualities are there, then we're pretty sure we haven't hurt the water any. So what are some qualities people have to live?
Food.
We got to have food.
Water.
Water.
Shelter.
Shelter. What am I missing? Food, water, shelter, air to breathe, absolutely. So those are all things that people have to live. And so just like we have to have certain things, the things that live in the water have to have certain qualities. So in the 4th grade, you guys did the scientific method, right? Mm-hmm. All right, so I think that maybe this might look a little familiar to you, and I've got it written on the board. In the scientific method, there's always a question, right? That's what you're trying to answer. So for TVA, for the Tennessee Valley Authority, our question is, when we generate your electricity, is the water still able to support aquatic life? So what's aquatic life? Aquatic life.
Fish and mostly all sea animals.
Oh yeah, things who make their habitat in the water. So our question would be, is the water able to support aquatic life? So since I couldn't take you to the Tennessee River, I went to a place called Cane Creek. You guys ever been to Cane Creek? Cane Creek Park? All right, so I went down there and I gathered water. Those are the paddle boats. Anybody ever paddle boated out there? Looks like fun, yeah. So as a scientist with TVA, we would do what's called a physical observation. First thing we would do is we would look at the water to see if it gave us any clues. And so we'd make observations. First thing I'd look for, like oil slicks. Have you seen a parking lot after it rains, how it's kind of rainbowy colored? That's oil and gasoline that's leaked from a vehicle, which is not good. And sometimes, because there's maybe boats out here, you could probably get some oil floating on top of the water from something leaking that you didn't know about. But I didn't see any of that. I would look for trash, water bottles, grocery bags, those paper, plastic grocery bags. Car tires. I don't know why people throw a tire to a car or a rim in a creek or a lake, but sometimes you see those. I didn't see any trash there. And there were some folks hanging out there. Actually, they were walking. And I talked to them, and they said they come here almost year-round. And I asked them if they'd seen any dragonflies. Did you guys see any dragonflies this summer? Okay. Dragonflies are really cool. They're what we call an indicator. They tell us things. And they can tell us about the health of the water. A dragonfly will lay its eggs on the water. If that water's healthy, those eggs will hatch and you get more dragonflies. And dragonflies eat mosquitoes. So we say, yay, dragonflies. So our overall observation, our physical observation, is no oil slicks, no trash, and reports of dragonflies. So can somebody kind of draw a conclusion from that? What do you think? If you're seeing dragonflies, what does it mean?
That you probably know that there's probably a lot of life in that water, and the water is very healthy and good for animals.
Somewhere around there, you're going to have some healthy water because you're seeing dragonflies. So in the scientific method, that's kind of that step that's called observation. So we know our question is, will Cane Creek Lake support aquatic life? We've done some observations. Who can define hypothesis for me? Hypothesis. Give it a try.
It's sort of like a prediction.
Absolutely, a prediction. It's kind of what you think the answer to that question's going to be. Sometimes it's called an educated guess. You're guessing the answer to that question, but it's not just a random guess. It's because you actually educated yourself a little bit. You learned, you saw, you did some observations. So, raise your hand if based on our observations and maybe what you know about having been to Cane Creek, raise your hand if you think your hypothesis would be, I believe the water at Cane Creek Lake will support aquatic life. I think there's going to be fish and tadpoles and minnows, maybe frogs, water snakes. All right, so it looks like 100% of us believe that Cane Creek Lake will support aquatic life. So another way to define hypothesis, it's sort of an educated guess or prediction answering our question that hasn't been proven yet with experiments. So today, we're going to do 4 experiments to prove or disprove our hypothesis. So you good with that? Mm-hmm. All right, good deal. All right, so every job has paperwork. And have you had homework yet? Yes. Okay, that's sort of your version of paperwork. So the scientists always have things that they write down their information in because the TVA scientists test a lot of water during a day, and if they would forget if they didn't write it down. So every science team is going to get this clipboard, and everybody's going to work with it. So when you get the clipboard, I want us to sort of hold it so that everybody can get familiar with it. And this is probably a good time for me to do some of my rules. I've got 3 rules. Right? My first rule is you've been divided into science teams of 3 or 2. Miss Lacey, am I looking cockeyed? Did someone leave? If I take a team of 2 and split it, will that make me 3? May we do that?
Yes. So Garrett, sit over here at Callie's table. Preston, sit beside TJ.
Thank you. All right, so now we are officially teams of 3. And as a science team, you know, teams work well together, they cooperate, they make sure everybody participates. So you're a science team, and your table is now your lab station. All right? So when your team gets this clipboard, I'm going to want you to be able to hold it so that everybody in your team can see it and get familiar with it. All right. If you look, there's several sheets on here. They're all the same. They're just set up for future classes. The top of it says data sheet. Well, some people say data. I say data. That very first column says parameters. Parameters means this is the area of information that we're going to work with today. We're going to get all the answers to all of these questions today during our experiment. The second column says example. So it's an example of how you're going to write your answer. And then it's got Site 1, Site 2, and Site 3. So if we were going to test a lot of water, we'd use all those sites. But today we're just going to record under Site 1. Okay? So you're going to read a chart, and you'll look under parameters. You'll look at your example, and you'll record under Site 1. If you look at example, under example, see where it says air temperature? It's got a little circle and an F. In science, that's called a unit of measurement. Does anybody tell me what that stands for? That little air temperature, that little circle in the F?
Degrees.
And degrees, what does the F mean?
Fahrenheit.
Degrees Fahrenheit. Does anybody know what that unit of measurement stands for? What are we measuring with that? Yeah.
Temperature.
temperature, absolutely. So see, you already know a science thing, really good. All right, water temperature's got a little circle and a C. What does that stand for?
Degrees Celsius.
Degrees Celsius, and what's it talking about? The C. Celsius is measuring.
Measuring the heat of the water.
Absolutely, it's measuring temperature. All right, so you already know some science terms. There's one that's got a ppm behind it. You won't learn about that till high school, but it means parts per million. And then the very last one says turbidity, and it's got a JTU behind it. You won't learn about that till college. But we're going to learn a lot about turbidity. But what you do know is these are the words, the symbols, the units of measurements that scientists use. And since we're doing science today, when you record your answer, all you've got to do is look over at your example and use that. Just copy that. All right, so first thing a scientist wants to know is, when am I doing my experiment? So if one person in our team would take the clipboard, and nobody likes my pencil because it doesn't have an eraser, but if we make a mistake, we just scratch through it and put the right one in. So today's date is August 8th. So if the first person would put August 8th, and then pass that clipboard to a second person in your team. And you're under Site 1, right? Under Site 1. Yeah, see where it says date? And there's your example, and you put it right there. Right over there, under Site 1. That's where we're going to record that.
What do we do here?
You're going to put the date, and you aren't going to do anything with that. That's just your list. This is your example. So if you'll put under Site 1, you're August 8th. All right, and that's where all your answers are going to go. Yeah, but we're not going to do that. We're going to put it right there. Thank you, sir. Yes, you may. Site 1. Yay. All right. So if you'll pass your clipboard to the second person in your group, or another person, a scientist wants to know when I'm doing my experiment. So see where it says location. It gives you an example. And then once again, under Site 1, we're going to actually test the water at Cane Creek Lake. Okay? Cane Creek Lake. So a scientist wants to know when I'm doing my experiment, where I'm doing my experiment. And we got Cane Creek Lake. And then the third person in your group, a scientist also wants to know, what were the conditions like when I did my experiment? Would you get the same conditions maybe in really, really cold weather, January, February, as you would hot August? So you might or you might not. Your hypothesis might change. So we're going to use the air temperature to talk about the condition. It was 78 degrees Fahrenheit when I collected your water. So on that third spot, if you look at air temperature and read across your example, you're going to put 78 degrees Fahrenheit. Everybody there? All right, then the rest of those blanks are going to be filled in once we do those experiments. Okay, so we know our question, we've done our observation, we have our hypothesis, we've got our data sheet set up. The next thing a scientist would do is check their equipment, all right? So we always have to make sure that we've got everything that we need for the day. You guys check before you come to school, make sure you've got your homework and your lunch and all the things that you're supposed to bring, permission slips. So every science team is going to get one of these containers, and I'm going to call it a beaker, all right? So a beaker holds more by volume than like a test tube, all right? So when your team gets this beaker, I only want you to hold it by the lid until I ask you to do something different with it. And when your team gets your beaker, I want you to look and see if you can find the fill line. It's a dotted line and it says fill. Got it? All right, that line is important. That line is going to show you how much water you're going to get from the buckets of water that I've got outside and bring back into the classroom. All right, so what's the fill line mean? How much water we're going to bring into the room. All right, now do you have a black strip? It's got a 40, and it goes around to 14, and then it's just black. And then does it have a number that's sort of green, maybe with a little brown on it? Like mine says 24. You guys got a little number lit up? All right. This is a thermometer. It's measuring in Celsius. We don't use Celsius much, do we? Scientists use it all the time. It's the kind of the universal science language. And since we're doing science, we're going to use what scientists use. So everybody's going to get to do this, but I want one person in our group, take your beaker and put your finger on the number 26. Just hold it on the number 26. Kind of make sure your team can see it and then let go. All right, second person in your group. Put your finger on, try the number 28. Lay your finger on 28. And then let go. All right. Put your finger, third person in the group, put your finger on the number 24. Touch it and hold it. Is it changing colors? All right. All right, so as you touch those different numbers, this thermometer has been taking the room temperature, and then all of a sudden a warm hand touches it. What's your average body temperature if you're not ill? 98.6-ish. So a warm hand touching this, all of a sudden that thermometer says, "Oh, I'm trying to change because something warmer is touching me." So one of the 4 things that we're going to test today is the water temperature. Why do we care about the temperature of water for our fish?
Because if it's too hot, then they couldn't have like the right temperature for their body to...
Absolutely. Some fish like really cold water, trout and salmon. Catfish like a warmer water. So TVA has to make sure that when we borrow the water from the Tennessee River to help generate your electricity, that we put back the kind of water that the fish that live in that area like. So let's say we didn't do that. Let's say at the steam plant, we've heated that water up and we release that water back into the river. Have you guys studied ecosystems yet? Yes. All right, so think about this with me. We put that water back in and it's just a little too warm. Well, I don't know about you guys, but if we're all the fish that are swimming in that area and that water's too warm, I'm going to leave. I'm going to go find some place where I'm really happy and it feels good to swim in again. What's it called when we all leave? Migration. If we migrate away, how does that affect your ecosystem? How would that affect your ecosystem? Yes?
You would move to a different place where you can actually live.
Right, and what happens to the place that we moved away from?
It gets used or it gets migrated from a different farm like that person goes there.
Absolutely. So if the food chain is affected, we've got a fish that snacks on us and we went away. What happens when that fish shows up for supper and we're not here?
He's going to be starving.
He's going to be starving. He's going to perish. And so what happens to the bear that wanders through, that eats the fish that just perished because we left?
It's not going to have any food.
Right. So isn't it crazy that something as simple as temperature can affect the whole ecosystem in our rivers and streams? All right, so now I want you to take the top off, and I want you to look inside. I want you to see if you've got a little black and white disc. Make sure your team members can see it. It just twists kind of off like a jar lid. All right, this is called a Secchi disc, and it's going to help us determine whether or not our fish can see very well in the water. It's called turbidity. Say turbidity. 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 It makes my lips tickle when I say it. Turbidity. It's one of my favorite words. So turbidity tells us how clear the water is. Well, why would we care if fish could see anything in the water? What do they need to see in the water? Yes, ma'am.
If they're about to get, like, eating something.
Absolutely. If their predators are coming up on them. So if they need to see their predators, what else do they need to see?
For the food. Their prey.
Their prey, absolutely. So this is our predator-prey situation. This tells us about our ecosystem. All right, so we've got our data sheet. We've checked our equipment. I think we're ready to do experiments. All right, so science team, we're going to do 4 different tests on the water. Every job, every test that we do has 3 parts. So everybody should be busy doing something. If you don't get the thing you want to do, it'll be okay. Something fun will be coming around the corner. You don't get to pick your jobs. I'm going to pick them for you. So if I'm handing you a glove and I'm just picking a glove, the person on the single side of the table. Thank you, ma'am. I'm sorry I missed you. If you got a glove, you are now what I'm going to call the water collector. All right? And so, water collectors, I want you to put the glove on your dominant hand. What's a dominant hand?
Your hand that you use a lot.
The hand that you're most comfortable using, that you use a lot. Sometimes that's the one you write with, but not always. If you've got a bracelet or a band or something that you don't want to get wet, move it to your other wrist. All right, so water collector. I want you to raise your right hand, and I want you to hand the clipboard and pencil to the person across from you on your right. Bingo, you're right, you got it. I'm telling you, there's tricky instructions here. All right, if you just got the clipboard and the pencil, you are now what I'm going to call the eyes. You are now the eyes of the experiment. And if you don't have the clipboard or the glove, you're going to be what I call the counter. All right? So, here's what's going to happen. Water collector, I want you to put your gloved thumb in the beaker opposite the numbers. Because what you're going to do is you're going to show your eyes these numbers. All right? Eyes, I want you to look at your clipboard. All right, you got your clipboard. See where it says water temperature? We're going to take the temperature of the water. It's going to show up green. And I want you to very quickly see the color that's green when it comes out of the water, and that's where you're going to record your answer, where it says water temperature, okay? Counter. You are like the beep on a thermometer. When you take your temperature at home and you put the thermometer under your tongue, can you just whip it right out?
No.
You have to leave it in there a certain length of time to get an accurate temperature reading, right? All right, so your job, counter, is going to be to count in your head 1 Mississippi, 2 Mississippi, 3 Mississippi. And then you're going to need to tell, when you get to 30, you're going to tell your water collector time, beep, ding. You're going to let them know that the thermometer has been in the water long enough to get a temperature reading. All right? And I'm asking you to count in your head. Why am I asking you to count in your head?
So you don't count out loud and messes other people up.
Yeah, so people just don't get all confused. All right, so here's what's going to happen. There are 5 buckets of water that I got from Cane Creek. All right? Water collector, you're going to go out with your team. If you are the counter, I'm going to assign you a bucket. And if you're a counter, the first counter that gets to that bucket is going to lift the lid up. The lid's not heavy, but it sort of takes 2 hands to pick it up. It's just a little awkward. So you're going to take 2 hands, pick the lid up off of the bucket and set it over to the side. There may be 2 people, 2 groups testing at the same bucket. So there's plenty of room for that to happen. One group will stick their beaker in. Pull your glove up on your hand. The glove is not to keep your hand dry. The glove is to keep from contaminating our water source. So I don't get hand lotion or antibacterial or leftover breakfast down in the bucket. All right, so counter's taking the lid off. Water collector's going to dip this under and hold it just at least so the top of it's underwater. Counter, as soon as this goes underwater, you're going to count in your head to 30, and then you're going to tell your water collector time, and then the water collector is going to stand up, show their beaker to their eyes. So, and go ahead and stand up. And and show it to them so they don't have to crawl on the floor. The water temperature may not have changed overnight, but it may have. But whatever the color is that's green is going to be the temperature. It may have a little brown in it. It may be brown with a little green in it. But eyes, take a look right now at your thermometer. And that color that's green right now is what you're going to be looking for, okay, when it comes out of the water. And then you're going to record that where it says water temperature. Let's see, water collector, you've got one more thing to do. After your eyes have recorded the temperature, you're just going to pour back into the bucket a little bit of water. How much are you going to keep? To the fill line. Very good. And then you'll bring that back in here to do more experiments. So here's a quick review. We're going to line up, you're going to stay with your group, and I'm going to assign you a bucket. If you're the first counter, you're going to take the lid off. Water collector, you're going to dip, hold. Counter's going to count in their head to 30. You're going to pull it up, show it to your eyes. Eyes, what color are you looking for? Green, maybe with a little brown on it. Where are you going to record it?
On your data sheet. On the water.
Water temperature part of your data sheet. Water collector, you're going to pour out water and bring up to the fill line back in. When you take your glove off, you're going to take it off and put it in the trash. It's easiest if you pull from the wrist down. If you try and pull by the fingers, sometimes it tries to get all vacuum sucked up on your hand. Okay, are you ready? Very carefully, let's let these tables line up, then these tables line up, and these tables line up. You'll need your clipboard, your pencil, your beaker. You can go ahead and start if you come around and make some room.
Oh, at least there's somebody here with me.
All right, so you're going to stick that all the way under. There you go. You don't have to stick your hand under, but that's pretty good. Once it goes under, you're going to start counting. Good. All right, how's it going?
Really good.
Really good.
And cold.
And cold. All right. Let's stand up.
Oh, wait, 22?
Hold up. Hold on to it. I'm just helping get it up here. 22. Okay. How much are you going to pour out?
Just to the fill.
All right. Did you get it recorded?
Yep.
All right.
22.
Pour.
This came off. Came off this.
Okay. Thank you. Got it?
But do we need the lid?
No. And you're just going to lean that back, just rest that back on there. You got it? Unit of measurement. Good. All right, and you're just going to lay that top back on there. Make it look like your example. What are you missing?
Oh,
Okay. Yes, and there's a trash can. You can take your glove off. It's inside the door. How you doing? Got it? All right. And when you get through, last person, don't tighten the lid. Just sort of lay it on there, and we'll go ahead and come back. You know you're going to break your neck on those shoelaces. Remind me to teach you my secret on how they'll never come untied. You got it?
I had the fun part.
All right, here we go. You going in?
Come on.
Yep.
Hold it. There you go. You got it? So if your hand's wet, just either shake it dry or sit on it. Oh, Miss Lacey's got paper towels. That might be better. All right. If you will take your lid and turn it up like this beside your beaker.
Well, what are those?
If you can make your lid look like these over here, guys. Take your beaker out of your, and they'll need you to take your glove off. All right. Let's see. Did I tell you that if I were going to need your attention, I would say eyes and ears? I think I forgot to tell you that. Okay. Right behind you. All right, scientists. From here on out, there are going to be times when I need your attention because I'm going to be showing you some things to do with some of your science equipment. And when I need your attention, I'm going to say eyes and ears. I'll say eyes and ears, please. And that means I need you to stop what you're doing and look at me for instructions. All right, so counter. You are going to take the lead in this next experiment with the help of the rest of your team members. You have on your little lid a little silver packet. It's got 2 tablets in it. It says DO on it. Check that. It's part of checking your equipment. Does it say DO? It may say do not eat. These are chemicals that will have a chemical reaction with our water sample. Have you guys studied chemical reactions?
Yes.
What's the sign of a chemical reaction? Bubbling is one. What's another one? Fizzing. What else is a sign of a chemical reaction? Smoke. These chemicals are actually going to give us a visual change. Things are going to change colors, and these tablets are going to help us see the oxygen level of the water. Why do we care about the oxygen of the level of the water? I mean, they're just fish.
Well, because even though they live in water, like there's a certain type of oxygen that's in the water. They still have to live.
How do they do that? How do they breathe oxygen? That's what you're telling me is they breathe oxygen. How do they do that?
Gills.
Through their gills, absolutely. So some fish love a lot of oxygen. Trout and salmon love a lot of oxygen. Leeches, not so much. So we want to make sure that the oxygen level is what it needs to be for the area and the species that live there. So, counter. On the back side of this, there's 2 like pillow puffs. Some people say it looks like gum or mint. If you turn this over and actually push on that pillow puff, those 2 tablets should come out. So I want you to take those tablets out, and I want you to give 1 to your eyes and 1 to your water collector. All right? If you need help getting your tablets out, just raise your hand. Got them? All right. Now, counter. I want you to look. This is a glass vial. It is glass. It will break. in science, if we were going to be using glass, we would probably wear goggles to keep it from breaking just for safety. Today, we're going to use the lid of our beaker, and that's going to be our safety feature. All right, so when this little glass vial is not being used, I'm going to want you to keep it horizontal in the lid of your beaker. What's horizontal? Sideways, okay. All right, so counter. I want you to take the top off and look in that little black lid. It's got a little thing that's called a plunger. See if your team can see that. All right. Now, on your glass vial, see that threaded part? That's what's called the neck of the bottle or the neck of the vial. So I'm going to show you what I want you to do, and then I'm going to ask you to do it. All right, so you're going to hold this by the neck. You're going to submerge it underwater. Well, hang on and let me show you what to do. You're going to push it under the water. You're going to count to 3. 1, 2, 3. You might even hear it go glug, glug, glug. You're going to pull it up, and it is going to be tippy top full. And you're going to hold it away from your water sample. And then the eyes are going to put in their tablet, and the water collector is going to put in their tablet. And this could be so full that those tablets sort of hover on top. And that's why this lid has that special piece of equipment in it. That plunger is going to push those tablets down to the bottom. So do that much, and I'll tell you what, then we'll go to the next step. Hang in there, counter. Stick that in there. You got it, you got it. Stick it in. Hold it under. There you go. All right. Now. All right, you got your lid on? You got your 2 tablets in? All right. Do you see some bubbling coming up? All right, that's the start of your chemical reaction. All right, so counter. I want you to put your pointer finger, your index finger on the black lid and your thumb on the bottom, and then turn your hand up. And I want you to make your hand sort of look like mine. You're going to do a motion in science that's called agitate. All right, so you're just going to twist from right to left, sort of like twisting in a light bulb or turning a doorknob. And you're going to do that for 4 minutes. All right, so you're going to agitate, and you're helping us get a chemical reaction to show us the oxygen level. All right, so while the counter is doing that, eyes, you're going to take the lead in this next experiment with the help of your water collector. Water collector. To help the eyes, I am going to give you a little packet that's been sort of pulled open. This is a chemical that's going to help us determine the acid level of the water. So you're not handling acid, you're not making acid. It's called the pH of the water. This tablet loves nothing better than to crush up and crumble. So I've made a little handle. So water collector, don't touch this until I ask you to, all right? And when the time comes, I will tell you what to do with it. All right? Do you know people that have swimming pools? Yes. So sometimes they'll check the pH of the water to make sure there's not too many chemicals. Have you ever gotten shampoo or lemon juice in your eye? Yes. You know how it burns? Yes. All right, well, that's what this little tablet is going to show us, is whether or not this the water has too much acidity or baseness in it. All right, so eyes, here comes the test tubes. Okay. All right, eyes. I want you to take the top off your test tube. I love that sound. Okay. Now, I want you to hold it up and see if you see a 10 milliliter mark. Can you see it? All right. So there are 2 steps to this part of the experiment. All right. The first step is we're going to fill this tippy top full of water. And then tippy top's a scientific phrase. Then we're going to get 10 milliliters of water. They're flying vials. All right. So, eyes, here's what you're going to do. This is plastic and it's going to tend to want to float. So you're going to hold it under the neck. Can you see? And then you're going to put this in the water, into your beaker. You may have to tilt it sideways. You may even have to tilt your whole beaker over sideways to get it to fill up. So go ahead and fill this tippy top full. And when you pull it up, all right, you got it full? All right. Now, eyes and ears. We're going to try and get 10 milliliters, and I'm going to show you the best way to do this, so I want you to trust me. I want you to slide your hand down your test tube and hold it at the bottom, like this. And then I'm going to ask you to lift your arm up a little bit, and you're going to bang it with your finger against the beaker. And every time you bang it, a couple of drops of water are going to jump out. So you'll have to stop and check and see when you get to 10 milliliters. All right, so when you get to 10 milliliters, oh, good. Oxygen, folks, you have agitated for 4 minutes. All right, so those chemicals are going to continue to work. So you guys go ahead and try and get your 10 milliliters. Counter, you're going to place this and lay it down horizontally in the lid of your beaker. Those chemicals are going to continue to work and kind of do their thing while they're at a resting state. All right, so eyes. You getting 10 milliliters in here? When you get 10 milliliters, I want you to hold it out real carefully. And water collector, I need you to try and pick up that little packet and dump that 1 tablet in there. And then put the lid on it. All right? All right, just hold on. Let's let everybody get caught up with us. We got our tablet in. We got the lid on. Okay. Eyes and ears. Eyes and ears. Eyes, put your lid on it. And then I want you to turn it upside down and turn it right side up. Turn it upside down. Turn it right side up. And turn it upside down and turn it right side up. All right. Okay, does it look like everything has dissolved? Do you have any little pink streaks still in it? Okay, if you do, turn it upside down again. All right. Good job. Okay, scientists, here's what we're going to do. I want you to lay your pH that's measuring the acid level of the water across the lid of your beaker, and we're going to let those chemicals just sort of continue to do their thing while they're just resting. So far we've checked our temperature, we've mixed up our oxygen, and we're checking our pH. The last thing that we're going to do to look for our water quality is that word turbidity. Turbidity. How clear is the water? How well can our fish see their predator and see their prey? So every science team is going to get what's called a reference card, and this is what scientists use to determine the results of their experiment. You're going to look at the word turbidity, and you're going to see that same emblem in the bottom of your cup. There's something that looks like a pencil mark on there. And that pencil mark is designed to lay on top of your cup so you can see the emblem in the bottom and the one on your card at the same time. This is going to be a team decision. You'll probably have to stand up and look down. And once you have determined what you think your turbidity is, you're going to record that on that last line right there. All right, here we go. So you may have to scoot it down to one end and stand up so everybody can look. Is your black just as black, or does it have a little gray to it? Eyes and ears. Eyes and ears. I've overheard a couple of teams say, gosh, it's not exactly black, but it's not as gray as the 40. So scientists sometimes have to draw a conclusion. So if you think yours is a 20, then that's okay. It may be spot on 0, and it may be spot on 40. And then once you've got that decided as a team, you're going to record that right there.
Don't touch that.
What? We're going to get to those just as quick as I can get to them.
And that one's just a little bit more.
All right. So has everybody got their turbidity? Did you guys decide what it is? Have you got it recorded on the last line of your data sheet? And you've got your unit of measurement. You got it? All right. The next thing I want you to do, I want you to take this tall test tube that is measuring the pH, the acid level of the water, and I want you to hold it in that little horseshoe area right in there. And you can swing it around. Does it look more like a 6, more like a 7, or more like an 8? And once again, that's a team decision. All right. Eyes and ears. Everybody got it? All right. Next thing I want you to do is hold your little glass vial that shows the oxygen level. And I want you to hold that next to, under where it says dissolved oxygen, there's just a little white space. And does yours look more like a 0, more like the 4, or more like the 8? And do you see where you should record that? All right, don't forget to record your pH. Your little green one. All right, eyes and ears. Anybody need a little more time to catch up with everything? Look and check your data sheet. Have you got your data recorded, and do you have your unit of measurement beside it? Does it look like the example? Okay, good job. All right, so I'd like for you to sort of put all your science materials over to one end of your table, and then I'd like for you to keep your data sheet handy, and then I'd like your eyes up here with me. All right. Wow, you guys did a great job. Nice, nice. All right, so here we are. We'll put all of our equipment sort of out of our way so we aren't tempted to fiddle with it. Keep your data sheet where you can reference it. You guys have just been plowing through the scientific method. Nice job. We know our question was, will Cane Creek Lake support aquatic life? We did our observations, no oil slicks, no trash, reports of dragonflies. 100% of us said, yes, I believe that Cane Creek Lake will support aquatic life. We did 4 experiments to test our hypothesis. You've recorded your data. All we lack are these last 2 steps. So, we did some fun things. We mixed up stuff and we shook stuff. Now it's time to think about what that really means. So, we tested the temperature of the water, and remember we talked about that affects our ecosystem. If fish migrate out or if they die off, it can affect the food chain. So around here, let's see, I'd like maybe each science group to report your results. So I'm going to call on your groups to give your scientific team's report. Can this team back here, would you tell me what your water temperature was? 22 Celsius, nice. What about you guys? 22? 22 Celsius? 22?
22 Celsius.
22? 22, nice. Typically fish like to live in maybe 8 to 30, but water around here, a lake, and in this environment, 22. Fish would be really happy with that. So, you know, I'm going to give Cane Creek Lake an A on its results for its test on temperature. The oxygen, dissolved oxygen, 8 is the best oxygen you'll ever get. But the only place you're going to see an 8 typically is where, maybe in the mountains where it's a little cooler and trees sort of hang over the streams and rivers and the water moves real fast. It bounces off rocks and drops over waterfalls. Have you seen whitewater rafting on TV? Yeah, or done that? So that all that movement pulls a lot of oxygen. But when we looked at Cane Creek Lake, it's big and wide. The sun was pounding down on it, not a lot of movement. So a TBA scientist wouldn't expect to find an 8. So let's see what you guys came up with.
We got
4 ppms.
Yep.
4?
Same.
4? 4?
4.
4? 4? 4. 4 is exactly what we would hope to find in water similar to that this time of year. So, looks like we got another A. Hope your report cards are going to look like this. The pH, the acid level of the water. Fish can swim in 6, 7, or 8. So, what did you guys have? 8? 8? 7? 8? 8? 8? 7. Okay, so we're in that 6, 7, 8 range. Looks like another A to me. So while we're talking about the pH, you know, we said that's kind of like getting shampoo or lemon juice in your eyes. Have you ever done that and it burns?
Yes.
Can you think of some things that might go into our water that would be changing that for our fish? What do you think of that might change that? Yeah.
Oil.
Oil, absolutely. Sometimes barges or boat traffic going up and down the water in the Tennessee River or its tributaries, they might add oil, and that might change our water. What's something else that can go in our water that might irritate, change the pH?
Trash.
Trash.
Because the fish can think it's food.
What else can go in our water?
Tires.
Tires, rubber kinds of things. Over where I live, we have a lot of farming. And so farmers have to be real careful when they add their chemicals to their crops. So the pinker that is, the more acidic it is. What do you got? Anything else you can? All right, so those are some things, acid rain, car emissions, factory pollution. So there's a lot of things we have to be careful of when we look at the pH of the water, the acidity of the water. So the last one we looked at was the turbidity. 0 means fish can see just as far as their little fishy eyes will let them see. 40, they could see around the playground maybe to see if something was coming up to snack on them. 100, just couldn't barely see in front of their face. So what was your team's turbidity? 20? 40? 40? 20? 40? 40? 0. All right, so when I went and waded out into the water, maybe that very first bucket that I pulled out might have been our 0. As I stirred around some of the sediment, maybe those second and third buckets I pulled out. So there are reasons that maybe we got different readings on that. So we've got 0s, 20s. How many did we have? Mostly 40s. Raise your hand if your team had 40s. 1, 2, 3, 4 out of. So I'm going to say a little bit more 40. So what kind of grade do we want to give it? B.
Maybe an A-. C.
C. Tough grader back there. What do you think?
A-.
A-. Remember, 0 is perfect.
So yeah.
40 is pretty good. What do we decide? B. All right. So, the last step in the scientific method is to actually draw a conclusion based on the analysis of our data. So, anybody want to try and state a conclusion? Anybody want to try and answer our question?
Aquatic life can live in it.
Aquatic life can live in Cane Creek. How do we know that?
Because they have all the right things they need.
Okay, they've got good grades on all their tests. Anybody else want to try and state a conclusion?
It has the perfect conditions for a fish, so a fisherman can have better luck.
All right, so, and as a result of having good quality aquatic life, fishermen are going to have better luck. Anybody else want to try a conclusion?
And animals will have better water to drink.
Absolutely, and those are going to give us our wildlife. It's going to have better water to drink. Anybody else want to try part of a conclusion? Wow, you guys did a great job. Jump in there for me.
It's good to populate it.
It's going to keep the water well populated with the species. And it would be better for us to swim in. All right, scientists, nice job. We've still got a couple of things we need to do, and the first thing we're going to do is we're going to clean up our science station. So here's what's going to happen. If you were the eyes, I want you to take the tall test tube. If you were the counter, I want you to take the little glass vial. Water collector, I want you to take your beaker and your lid, and I want you to return your water to the bucket that it came from. If you are the eyes, I have set a little cup out on your table. Yes, sir? You don't need it. You're just going to pour it in. All right, eyes and ears. If you're the eyes, I want you to take the top off of your test tube and pour the content in that little cup. If you are the counter, take the lid off of your little vial, and in that same cup, you're going to dump the content of your oxygen. And it may have made a vacuum, so you're just going to have to tap it and dump it down in there. It may have made a vacuum, so to break that seal, all right, so both of those are in there. Would you do me a favor? Would you go from table to table and collect those? Will you go from table to table, bang it against the side? Would you do me a favor? Would you go around and collect all of those?
Yes.
Thank you. Will you do me a favor and go and collect all of those? And then my water collector, are you the water collector?
Yes.
How about if, thank you, I'm going to let you go dump that, and if you'll go collect those for me. All right, if you'll make sure that your team members' names are on your paper. And Miss Lacey would like first names and last names. How much time have we got?
About 3 minutes.
Okay. So do I have speakers should go up here. I know. I think it'll be interesting to see if it does the same thing. Your name's on your papers. All right, eyes and ears. It just sits right there. Go ahead. I need bottoms in seats. As your bottoms in seats, please. All right. As you guys are writing your names on your paper, we got a couple of minutes. I'll try and do this real quick. Did you know that Earth is called the blue planet?
Yes.
Okay, because from space, if you look down, it's so very blue. Well, that's how much of the world is made up of water?
75%.
75% of all of the world is water. Can you go out and just drink any of that water?
No.
Why not? Ah, so I heard over here 97% of all the water in the world is salt water. And you know, salt water is worse for you to drink than regular water. It'll dehydrate you quicker. So what percent of all the water in the world is left? 3%. So I use an ice cube tray to remind me 2% of that water is frozen. So it's glaciers and polar ice caps and icebergs. So what percent does that leave?
1%.
So if this is all the water in the world that's salt water, and this is all the fresh water. This is all the water, represents all the water for everybody in the whole wide world to drink. How many continents are there? 7. So this is not just the water for Tennessee or North America. This is for everybody. How long can you live without food?
3 days. 7 days.
A week to 2 weeks, depending on the situation. How long can you live without fresh water?
3 days.
Depending on the situation. So we have to have our water to drink. So this natural resource, Cane Creek Lake, all of the water that's around you is really, really important. So TVA works real hard to make sure we take good care of the water that we work with. And so what are some things you guys can think of that you can do?
If you're taking a bath or brushing your teeth, you don't leave the water running.
Absolutely, that's called conserving water. So when if you're brushing your teeth, you just don't let it run. It goes right down the drain. What's another way you can take care of your water? What?
Electric cars.
Using things that might not pollute, and that would change our types of things that float into our water. Take shorter showers. That's all conserving water. Have you ever heard of recycling water? Sometimes people will get a rain barrel and catch rainwater out of the gutters, and then you can use that water to water plants or wash your car. It's just fine for that when you're not using good drinking water to do things that regular rainwater would do. What happens if you got a glass of water and you decided you didn't want it all? What do you do with it? Well, you could water a plant with it. You just put it back on the shelf and wait for, on the counter and have it later. You guys did a great job with science. What do you think?